What's up everyone, Patrick here, welcome back, and in this video what we got to do is find the domain and range of both of these functions here. So starting with number one, we got 12, or f of x equals 12 minus x squared. So notice here that this is a parabola, and if we, let's kind of rewrite this here, if we rewrite it like this, notice what we're doing is we're taking that parent function x squared, which basically looks like this. And then this negative in front, what it does is it flips it along the x-axis, and then we're shifting it up by 12. So the way this function is going to look visually is basically like that, where this point here, this vertex, is at 0 and 12. And so the domain for a parabola, we know that it's always going to be x as an element of real numbers. If you want to put this in interval notation, you could say from negative infinity to positive infinity, like that. That's what the domain is, right? The x values can be any real number. Now the range, though, y can be anything. However, notice that all the y values have to be less than or equal to 12, like that. And if you want to put this in interval notation, basically the y values can be anything from negative infinity, right, because this keeps going down forever, all the y values to all the negative y values, so from negative infinity to 12. So we could say from negative infinity to 12, and it's inclusive of the 12 right here. So we put a square bracket there. All right, so two different ways to express the domain and range for this function. Now this function here, f of x equals -3 over the square root of 5 minus x, this one's a little bit tougher. Notice that, first off, within the square root, we know that you can't square root a negative. Right, so we know that this expression here has to be greater than or equal to 0. If we're just looking at the square root, any expression under a square root always has to be greater than or equal to 0. It can be 0, you could square root 0, or it has to be positive. You can't square root a negative number. Now if this was the third root, then it would be a different story. Then you can have a negative, or if you had an odd root, like the third root or fifth root, then you can have a negative, but because it's a square root, we can't have a negative. But if we look at not just the square root, but the overall function, notice that this also can't be 0 in this specific case because the square root is in the denominator of this whole function. So if, for example, if we got 0 here, if x was 5, 5 minus 5, which is 0, square root of 0 is 0, but we can't take -3 and divide it by 0. And so for this overall function, so this here is just for the square root, but if we look at the overall function, 5 minus x actually has to be greater than 0. It can't be equal to 0 because it would make that function undefined. And so notice that x has to be less than 5. Right, so that's what the domain is right there. X has to be less than 5, so the domain would be x can be anything as long as x is less than 5, or in interval notation, basically all the x values from negative infinity to positive 5, not inclusive of the positive 5, so that would be a circle bracket right there. Now the range is a little bit tougher. Basically, what's going to happen, first we have to check what's going to happen as we approach 5 from the left side, right? Because all the x values have to be less than 5. So what would happen if we plug in, let's say, 4.99999 for x? Well, notice we would have 5 minus 4.999, which would give us a very small number. Square root of a very small number is another very small number. And then notice we'll have a negative number divided by a very small positive number, which would give us negative infinity. So basically, as x approaches 5 from the negative side, the y values approach negative infinity. Right? So there's going to be a vertical asymptote there. So what's going to happen is at positive 5, there's a vertical asymptote. And as we approach positive 5 from the negative side, can't approach it from this side, right? The function doesn't exist on the other side. So as we approach 5 from the negative side, the y values are going towards negative infinity, like that. And then what's going to happen as we notice how x can also go to negative infinity, right? We could have a very large negative number that we could plug in here because we'd have 5 minus a very large negative number, which would be 5 plus a very large negative number, right? Notice x can be less than 5, so we can go towards negative infinity, right? That would always make the denominator defined, that square root defined, because we would end up with a positive number here. And so notice as x goes towards negative infinity, what we're going to end up with is a very large number here. The square root of a very large number is another very large number, a very large positive number, and then negative 3 divided by a very large positive number gives us 0. And so the y values are actually approaching 0. And notice the y values are always going to be negative because this denominator, it's always going to be positive over here for all the x values that are less than 5. No matter what we plug in, square root, it's going to give us a positive number, and then negative divided by positive is always going to be a negative number. And so the way this function looks is like that, basically. Right? So as x approaches 5 from the negative side, the y value goes towards negative infinity, and then as x approaches negative infinity, the y values go towards 0. And then from there, from that information, we could state what the range is of this function. Notice that the range is basically y is an element of real numbers as long as y is less than 0. Now, less than or equal to 0, less than 0 never touches the y value 0. There's a horizontal asymptote there. So all of the negative y values, basically, that's what the range is, or you can show this as negative infinity to 0. All right, so for this function here, that's the domain, that is the